Good morning, students. Let us have continuation of examples on limits. Okay. In the previous class, we have discussed about the examples whether the given function exists or does not exist. Exist means what? LHS should be equals to RHS. Okay. If LHL equals to RHS, the given function exists. If LHL equals to RHL equals to that given point, then the function is said to be continuous or discontinuous. Okay, continuity examples we will discuss in the next class. Let us have continuation of examples on exist, does not exist. Okay, so in the previous, here the question is find for what value of p does the limit of f of x as x tends to 1 exist. Here the function is defined like this: f of x equals to this given function if x is less than 1, x is greater than 1. We have to consider the function for LHS x is less than 1. If x is less than 1, for that we have to consider that function as a LHS, that is x tends to 1 minus. For x is greater than 1, we have to consider this function for RHS value. Okay, that is for x is greater than 1. Once again repeating, for x is less than 1, it is LHL value. For x is greater than 1, we have to consider that function for RHL. Okay, here the question is they himself given that the given function exists. You have to find the value of p. Okay, function exists means that LHL equals to RHL. Clearly they have given. You have to only find the value of this unknown quantity p. First you have to consider that LHL value f of x, x tends to 1 minus. For x is less than 1, we have to consider the function as 2px plus 3. Okay, limit of this function as x tends to 1 minus. If you consider h tends to 0, x tends to 1 minus h. In place of x, you have to substitute 1 minus h. Here both are same. If h tends to 0 means it is 1 only. For h tends to 1, so both are same. Okay, for exponential function, this h should be helpful. So we have to consider the function as h tends to 1 minus. H tends to 0, h tends to 1 minus h. Okay, plus 3. If h tends to 0, it becomes 2p into 1 plus 3. 2p plus 3. Okay, so this is LHL value. Similarly, RHL value, you have to consider this x is greater than 1, 1 minus px square. Limit of f of x, x tends to 1 plus, that is for LHL greater than 1 value. So we have to consider as h tends to 0, x tends to 1 plus h. In place of x, you have to substitute 1 plus h. Okay. Again, as h tends to 0 means you will get 1 minus p into 1. That is 1 minus p only. Okay. So they himself given that the given function exists means LHL equals to RHL. That is the given function exists. That is given. So if these two values are equal to p plus 3 equals to 1 minus p. So take this p on this side, so it becomes 3p equals to minus 2, therefore p equals to minus 2 by 3. So this is the method how to find the value of unknown quantity, suppose the given function exists. Okay. In the similar way, we have to consider another type of example. If f of x equals to function is given, x is greater than 1, x equals to 1 by 2, x is less than 1 by 2. Here given function is show that limit of f of x as x tends to 1 by 2 equals to 1. Both questions are same, only the way of asking is only different. Here given function equals to 1 as x tends to 1 by 2, or they may ask show that the given function exists. If that function exists means that value should be 1. So this is the question. Okay. LHL you have to consider limit of f of x, x tends to 1 minus 2. 1 by 2 minus means you have to consider that function that is less than value, that is 2x for LHL. This is for RHL. This function helpful in continuity. Okay, in continuity it will be helpful. Okay, here it is not required. 2x, x tends to 1 by 2h. If h tends to 0 means x tends to 1 by 2 minus h. 1 by 2 minus h. In place of x, you have to write 2 get cancelled. If h tends to 0, here the value is 1. Okay. Similarly, RHL value, limit of the function that x tends to 1 by 2 plus h. 1 by 2 plus x, you have to consider the function x is greater than 1 by 2. So you have to consider x plus 1 by 2. As h tends to 0, x tends to 1 by 2 plus h. Okay, so h tends to 0, 1 by 2 plus 1 by 2. Here LCM is 2, 1 plus 1, again it becomes 2, so it is 1. For LHL and RHL, both the values are 1 only. LHL equals to RHL equals to 1. Therefore, the given function exists. For what value? That is 1. Therefore, limit of f of x tends to 1 by 2 is 1. Okay? Here, both the questions they ask either this or this. Whether the given function exists or limit of f of x tends to 1 by 2 equals to 1. Okay?